Hello Internet, welcome to Maxin and Relaxing with Bob. That is me. Today we're going to be looking at bringing sprite sheets into Max and creating a sprite sheet player using jit.pix. We're going to look at implementing a really simple overblend mode in jit.pix as well. We might even look at whatever the hell this is. We might. What the hell is this? What's this? Okay, here we are again in Max, and we're once again working on this little MIDI drum pad video loop NFT project that we've had a look in the last couple of videos. Made a little bit of progress on it. Let's have a look at where we're at the moment. Just hook this metronome up so that it is automatically previewing. We've looked at so far debugging the seek object to read in a MIDI file, strip out the notes. We're setting some cells in a matrix to sort of animate it, and then we're compositing a couple of different layers together. What we've ended up with is this. I don't mind it. But I was playing around with sort of overlaying some images over the top of it, and it just wasn't looking the way that I wanted it to look. Wasn't quite getting there. And I figured I could keep persisting in Max and sort of try and steer towards the end result that I wanted, but just aesthetically it just wasn't getting there. What the aesthetic that I had in mind is really lo-fi 8-bit pixel style graphics, and this is essentially procedural animation, right? Creating a curve, like a gradient that is being triggered by MIDI. What this really needed was some element of hand animation, and so I had to look at some options as to how to do that, and I found online some pixel art tutorials by, oh my god, what's their name? I feel really bad that I can't remember this person's name. They put some pixel art tutorials on using this particular application, Sprite. Australian guy, I think his name is Adam. Pretty sure his name is Adam. Adam, thank you for your tutorials. Oh my god, so useful. And so what I put together with the help of those YouTube tutorials was this. So this is a sort of a pixel graphics style drum pad with all of the keys animated at once, with this little sort of like plaque down the bottom where I can put some text, and I've got a couple of different layers going on so I can control how grimy and dirty it is, and I can change my colors to essentially change the palette that we're using, which is ideal, just what I wanted, and it's aesthetically much closer. I mean, not even much closer. This is what I wanted it to look like. So Adam, oh my god, thank you. I hope your name's Adam. Pretty sure your name's Adam. So wonderful application. I'll put a link to his tutorials in the description as well. If you want to play around with pixel art, very enjoyable. Love the animation process. Really missed animating, so this has been really enjoyable to work on. So out of Sprite, you can export a variety of formats. You can export a GIF, but one of the formats that you can export is a sprite sheet. So what I am going to do next in this little project that's turning into a much bigger project than it was supposed to be. This is really just like playing around with the form of NFTs, right? This idea that you can have procedurally generated items, and generally that procedural generation has to do with graphics. So you have multiple layers and you combine those layers in different ways, and then you get all the different combinations of layers, and then, you know, there's a way of producing a lot of unique digital assets. I think as far as that applies to music, it's an interesting area, because there's sort of you know, explorability. There's some fertile ground to explore there, and so that's anyway. That's aside the point. I just wanted to play around with the form, and it's turned into a bit more of an exercise, which I'm really quite enjoying. So I think a lot of this part of my patch down here, I'm just going to discard. Where I'll probably still use this mask to be able to pick parts of my sprite sheet, because at the moment I've got all of the keys animating at once. I'm going to need to isolate different parts of my sprite sheet. But a lot of this I'm going to discard. And what I need to be able to do is to read in a sprite sheet and then animate it in Max. That's what we're going to do today. We're going to look at building a sprite sheet player. So let's have a look at the sprite sheet that this outputs. My sprite sheet out of a sprite. I've got 5 layers in my particular sprite. I've got sort of the base layer, some grime, the keys, and then this little overlay plate thing in both a clean and a grimy version. So top to bottom they're my layers, and then left to right are the frames of the animation. This happens to be 5 frames of animation, 5 layers. But this is how all of that information for multiple layers and multiple frames is all contained within this sprite sheet. So it's a very tidy way of working with animation. And also aesthetically, it's really quite a pleasing aesthetic as well. So what we need to do is to read this into Max and then have a way of picking which part of this image we're looking at. And we want to be able to specify this by layer, and we want to specify it by frame so we can animate it. So let's do that. I'm going to once again work in Gen using a jit.pix. I might actually just start a whole brand new patch. Let's do that. Alright. I'm going to close this. I don't think I need it. First thing I'm going to do is drag in my sprite sheet. My sprite sheet's a PNG, so it has transparency in it. If I drag it in, it comes in as an fpic object, and that's good. That's what I want to be doing at the moment. I could also, I mentioned this in the other video, I think, if you drag in and hold Alt, you can create a message box with read. Gives you the path to the file. So I'm going to do that as well, just because I might want to change this later. And so now I've got a way to change it. I'm just going to make sure that this actually, yeah, no errors, so we're good there. And I'll hook a load bang up. Very nice. So the next thing I want to do is to put this into a matrix. Let's do that now. And I'm going into an fpic before a matrix is, I tried loading the image straight into the matrix and it doesn't seem to like reading PNGs, but going through an fpic works fine. There are probably other ways to read a PNG in, I'm sure, but this works for me. And then if we hook a P window up to this, getting any information in, and that's because we need to bang our matrix. But more than that, so this won't work either. More than that, we need to also bang our fpic into our matrix. So I'm actually going to pop my, this mouse is terrible. Okay, it's see if this works better. I'm gonna hook this bang up to my FPIC and bang my FPIC, and now I can see that my matrix is being output from this jit.matrix. And this is our sprite sheet, 5 frames across, 5 layers down. So we know that's working. Mousepad attempt 2. So let's insert a jit.pix now, and we'll start working in the jit.pix to try and select a certain part of our matrix. I double click on my jit.pix to start editing it. Again, like I really like working with jit.pix and jit.gl.pix. There are definitely ways to do what I'm about to do in Jitter without using Gen. Jit.pix is my favorite object, and there's another advantage to like just using your favorite object. The other advantage is that if I wanted to be operating on textures instead of matrices, so if I wanted to optimize this for a graphics card, especially if I wanted to say be outputting to a projector or outputting to a screen, I could use the exact same guts of my jit.pix in a jit.gl.pix, and I would get a hardware accelerated version of the same operation. So that's quite a convenient way of working. I can do all of these matrix operations, and if I want to work on a texture later, I can do that too. Okay, we'll start by just outputting our texture. Look over here. At jit.pix, I'm getting my matrices, and if I my matrix, I always get the plural and the singular of matrix and matrices confused. I figure if I just keep making that mistake, maybe like everyone else will catch on and start making the same mistake, and then that's just what will happen to language. That will be, I will be proven right. That's what I hope happens. We can test that our jit.pix object is working just by like outputting a color. So I'm going to create a vector. Whenever we're working in jit.pix, we're working on, as far as color goes, we're working on a 4-component vector, RGB and A. So if I say R as 1, that's full red, and I'm going to say 0, 0, 1, and this is full red, no green, no blue, full alpha. If I hook this up to my output, we should get a red image. Do I need to bang it? What am I doing wrong? Why that's not working. This might be a difference of jit.glpix and jit.pix. I'm gonna forget I said anything. If you want to test your matrix, you just can't. Oh, hang on. Let's stick a metronome up here. Hey, let's go Q metro 16. I'm gonna set it to active 1. So I don't need to hook up a toggle to turn it on. It's just going to be running. I'll hook it up to my bang. Cool, we can see that's going. Okay, I think this should work. This should work, right? Okay. What was happening there? I think perhaps I hadn't sent this matrix into this jit.pix, so we didn't have a matrix on which to operate. That was the problem there. Okay. So we're up and running. It's difficult to explain. It's difficult to describe how bad this mouse is. It's terrible. It's terrible. I'm gonna have to do something about that. Okay. Whew, we've got all of that. We've got our jit.matrix working. So just put my matrix back out so we can see that we're getting our matrix in here. And what we want to do is select just this top cell, so the first layer in the first frame. To do that, we're going to read in our coordinates, that is, what pixel are we currently looking at in our jet.pix. I'm going to do a little bit of maths on it to resample our image. Let's have a look at how that works. I've got a an image. Here. Say my image is 500 pixels down, pixels across. Here is 0, 0. This point here is 500, 500. I read a pixel. What I'm doing is I'm sending in a coordinate. I'm saying, hey, I want to look at this pixel. This coordinate might be, let's say we're looking at this coordinate here. If we say 0, 0, that's what we'd be looking at, right? We'd be saying, I want this top pixel. If we wanted to read this bottom pixel, that would be 500. Actually, no, let's scratch that. Let's say we wanted to read this pixel here. This would be 500 and X and 0 and Y. That's position of 500. What I do is I can intercept my coordinates that I'm sending in to sample this pixel over here, and I can do a little bit of maths on them. And if I do maths on that coordinate, I can say, hey, no, don't sample that pixel over there, sample this pixel over here. So in this case, I've got a 5, oops, for 5, I've got 5 clearly evenly spaced cells. I mean, you can just tell by looking at it. It's perfectly aligned. Okay, great. So I've got a 5 by 5 grid. Let's say we were to take my X position and divide that by 5. Well, now my position 500, 0. I'm going to divide my 500 by 5. That's going to give me 100, 0. It's going to be this point here. So that means if I'm sending in a value from like 0, 500 to, sorry, 0, 0 to 500, 0, instead of being this whole range from here to here, it's going to be this range from here to here. So then I'm just selecting that top, oh sorry, the leftmost slice, leftmost fifth of my image. That's what we want to do in our jet.pix. Let's have a look at how that works. Now, there's a few different ways to sample in jet.pix. I'm working with pixel art, and I'm sampling at a pixel level, so I want it to be pixel accurate. Often if you're working with video, you sort of want to interpolate between, you want sort of a smooth image, you don't want like jaggies all over the place, so then you do what's called interpolation. In my case, I want it to be pixel perfect. So I'm going to work with pixels. The objects that I need to work with pixels, one is cell. That's going to give me X and Y in pixels. And I'm going to want to sample my image at a particular coordinate. So this coordinate, this cell, is that coordinate coming in, my 0 to 0, 500, 0, or my 0, 0. I'm going to want to sample. I'm going to want to sample using the nearest pix sample mode. There's a whole bunch of ways to sample in here. If we have a look in my little plus down here, my gen operators, and sampling, I can pick nearest pix, sample, and sample pix. The ones with pix work on pixel coordinates. The ones without pix work on normalized coordinates, so 0 to 1. Again, we're working with pixels, so I'm gonna do everything in pixels. Often I find it easier to think in pixels. It's a little less generalizable, but I do like working this way, especially with low resolution images. So if we were to just pop our coordinate in here and pop our image in here, we get exactly what we would expect. So here's our coordinate in, here's our image that we're sampling. But if I was to divide this by 5, because we happen to know we've got 5 frames and 5 layers, donk, I get the top left cell in my 5x5 sprite sheet. And this is actually applying divide 5 to both my X and Y. That's great if I want to pick the top left layer, but I want to be able to separately specify the frame, that is the cell in X, and the layer, that is the cell in Y. So I'm going to separate my coordinates so I can act on them independently. Do that or use Swizz. Swizz. Out my X component, I'm going to swizz out my Y component. This is just picking the first two components in a vector. So whenever you're working in jit.pix, you're working with vectors, just groups of numbers, collections of numbers, usually 4 numbers, R, G, B, and A, or X, Y, Z, sometimes W. That's just shorthand for the first indices of a vector. So X, if I was to say swizz X, that's exactly the same as R. So RGB is exactly the same as XYZ, as to paraphrase inaccurately a famous song. So I'm going to swizz out X, but divide my X component by 5. I'm going to just join these back together. We'll use a vector object. I'll give it 2 arguments because I'm working with an X position and a Y position. That gives me 2 inlets. Put this together. Now you can see that I'm picking from left to right. I'm sort of like stretching my image. So instead of going from 0 to 500, I'm going from 0 to 100. And if I was to do the same operation on Y, oops, again, I'm picking just the top cell. This is functionally exactly what we had before when we were just dividing by 5. It's just now we can independently operate on our X and Y, which is what we want to do. So the first thing I'm going to do is get this animating, and to get it animating, I need to step through my sprite sheet like this. I need to go donk, 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 donk. I want to be able to offset where I'm sampling at X, and I need to know how far I need to offset it by. To do that, I'm going to get the dimensions of my overall sprite sheet. I'm going to divide that by 5, and that's going to tell me how wide one of my frames is. So to do that, I can use the dim gen operator. That gives me the width and height of the image. It might even give me, like, I actually don't know if I was to pass in like a multi-dimensional texture, 3-dimensional texture, would this give me Z as well? I don't know. So I'm going to swizz out X. While I'm at it, I'm going to swizz out Y because I'm going to need to soon anyway. My sprite sheet happens to be square, so these should be the same. I take my width, I'm going to divide it by 5, and that's going to tell me how wide a frame is. I'm going to use this value to offset my frame. So I'm going to need to introduce a parameter now. Let's introduce 2 while we're at it. I'm going to create a parameter, frame, and I'll give it a default value of 0. I'll do the same for layer. And I'm going to multiply this by my frame. It's a parameter that I'm going to pass into my jit.pix object, and I'll use that to step through my animation. Set up. So I've got, I'm basically creating another vector. I'm figuring out how wide and how tall my individual sprites are in my sprite sheet, and then I'm multiplying them by a parameter which should allow me to offset in X and Y, which is offset in frame, offset by layer. I'm going to close my gen patch now. I think that's going to work. Side note, this is unrelated to this, but check this thing out. So I found this like just floating around on the internet. I don't know if I'll be able to get this to focus. Let's see if I can go there. This is it's called a D-stack. It is an ESP32 microcontroller with a little OLED display and an SD card slot and some buttons and a battery and a charging circuit and a buzzer and a light. I'll turn it on. Default firmware just beeps, and you can turn the flashlight on. I found this like just poking around on the internet. It's designed as a Wi-Fi hacking tool. It's used to de-auth networked devices, which is basically like kick them off a wireless network. So like hackers will go around like very inconspicuously wearing their they're like I'm a total nerd hacker watch, very secretly like pressing buttons, and then they'll kick all of the devices on a wireless network off the network, and then when the devices reconnect to the network, they capture the traffic, and that traffic's encrypted, but they can then decrypt the traffic like offline on another, like just offline. So like, you know, you can have days or years just run it, and then eventually you get passwords. Terrible thing to do not do it. But how cool is this? The reason I got this is because it's a little networked, battery powered screen with buttons and an SD card slot. So what this would be great for is as an OSC device for monitoring OSC on a network, capturing OSC on a network, and playing it back. Like, what a great little device. So like, I've got a lot on my plate, but that's something that I really want to get to. So let's see. No promises, but I might get to that in a later video. Side note, where was I? What were we talking about? We were talking about something. Sprite sheets. We're talking about sprite sheets. So we've created a parameter for our jit.pix. We've created two parameters. Let's test them out. I'm going to create a message box. Let's try just like shifting over to the next frame. Hey. So I should be able to say frame $1. Let's make a metro running at like 100 milliseconds. Active 1. Plug it in. Counter. That's not going to do anything. That's just sending out bangs. We'll make a counter, and I'm going to need to wrap the range of my counter. So my counters would just count up indefinitely. I've only got 5 frames, so I need to wrap around 5. So let's say counter 4. That will go 0, 1, 2, 3, 4, which is 5 values, 0 to 4. Plug this in here. Plug this in here. Hey, animated. Animated. Now, I should be able to send my other message, which is layer. Let's try layer 1. Actually, let's try layer 2. That's a more interesting layer. Layer. What did I do that? Plugged it into the wrong thing. Hey, there's my buttons. I got a frame. I got buttons. Go back to layer 0. Hey. Sick. Okay, this is good. This is good. We've got a working sprite sheet player. That is absolutely going to do what I want it to do. This is the cool thing about sprite sheets, right? We're controlling the frame independent. We're controlling the frame very specifically. All of our frames exist on the same sprite sheet. So I'm just gonna, up here, I'm gonna make a send. I'll call this send sprite sheet. And I'll make a few of these. I'll make one for each layer. I'm actually just going to pick out 3 layers. I'm just going to do my background, my keys, and this little overlay. And importantly, we need to drive them all with the same metronome, so they all stay in sync. I've got 3 sprites. They're all playing in sync. Now we've essentially got 3 animated layers with alpha that are all going to remain perfectly in sync, and we can now layer them, and we can use their alpha channel to layer them. So what we're going to do is implement a blend mode. We're going to implement a really simple over blend mode. Little tip, I do this all the time. Often I'll create a blank comment, and I'm just going to like plonk it down and to the right. Means I can gives me a little bit of space to work. I can like scroll down here, which is really handy. So let's layer these first 2. I'm going to create a single jit.pix object that does an overblend mode, and then I'll just duplicate that jit.pix if I want to do another blend mode, or if I want to blend another layer. So I'll say jit.pix. I'll keep my P windows there, because why not? We're working with tiny images, we can totally get away with it. If I create another P window here, this has created an additive blend mode. So we do have 2 layers on top of each other, but they're not blending quite the way that I want. You can see these magenta buttons are actually quite a bit brighter than they should be, and the shadow from the base, see how it's got this sort of shadow here? You can see that's bleeding into the buttons, so that's not quite what we want. What we want to do is use the alpha from our buttons to say, is it transparent? If it's transparent, show the background. If it's not transparent, show the buttons. Now this is a simple blend mode because I only have fully opaque or fully transparent layers. I don't have any actual opacity going on. So I'm going to do a really simple over blend mode. So what we need to do is swizz out the alpha from our top layer. I'm also going to swizz out the red, green and blue separately. No, I'm not. Yes, I will. Yes, I will. RGB. Yes, I will. So now we've got 2 separate vectors, a vector of a single element, which is our alpha, and then another vector, which is just our RGB. And then I'm going to create a ternary operator. I'm going to pass my alpha into the first inlet of my ternary operator. So this is going to look at the alpha, and it's going to test the alpha. Is the alpha 1? If the alpha is 1, then that means our key, our first layer, our key is opaque, and we want to display the key. So if alpha is true, we're going to pass in our RGB. And I didn't pass in the full image. We're going to worry about like what happens on the other side as far as alpha goes. So if this goes in, it's either going to discard alpha, it might pass it through with an alpha of 0, or okay, I'm not going to worry about that. I think this will work. I think this will work. It might be a technical hiccup here, but we won't worry about it. So if alpha is 1, then I'm going to pass out my key image. If alpha is 0, I'm going to pass out my background. Let's hook that up. Simple over blend mode. That's working. All of my keys flashing at the same time. Let's do that again. This is my over blend mode. If I was to do this if I was to do this for like a production sort of thing, like I would be saving my over blend mode as a separate patch so that I could instantiate it essentially as an abstraction. Then if I was to make a change in one of these, it will get propagated through the rest of my patch. I might end up doing that as I develop the patch, but for the moment, for just testing, we're just sort of roughing this out. Hook another P window up. I've got 3 layers being blended over the top of each other. So first I'm putting this on top of this, and I'm putting this on top of this. And there we have it. I think we might leave it at that. So quick recap, hey, we looked at bringing a sprite sheet into Max. We looked at how we can resample a sprite sheet using jit.pix, looked at using parameters to step through those, and then we looked at using jit.pix to create a really simple over blend mode to recomposite those layers together. thing to keep in mind, of course, is we're working with jit.pix here, so we're working on matrix operators, mops, but if you wanted to do anything that was more GPU intensive, or in particular if you were doing something where the output is to a screen or a projector, that is, if your graphics card is your final output, then running on your graphics card is much more efficient. In my case, I want to save these frames to disk, so that means it needs to go through my CPU. So in my case, at least at the moment, working on matrices probably makes more sense. But if I was to do this in a video performance context, then I'd be working on the graphics card instead. So we looked at creating an overblend mode in jit.pix as well, and now we have some little flashing squares. Oh my god! So hope you got something out of that. Please, any feedback in the comments. I'd love to know if this is useful, or anything. And subscribe. Thanks for watching.